Welcome back to the Deep Dive. We're the place where, well, we don't just skim the surface, do we? We go deep.
Right down to the bedrock.
Exactly. And today, take a deep breath because we are going way, way up. We're talking about engineering that works at the absolute edge of what's possible.
Yeah, forget the usual stuff. Ski lifts, tourist gondolas. That's not what this is about.
Not at all. We're diving into aerial transportation. Think ropeways, cable cars, but also these incredibly specialized cranes. Systems so big, so vital, they're basically lifelines for a nation.
They completely changed the game for logistics, for security, for building huge infrastructure projects in places where pretty much nothing else can even operate.
It's this whole field of engineering excellence that honestly most people never see. It's kind of hidden away, right, up in these super high mountain passes or across massive gorges.
Tucked away in industrial canyons, exactly. And these things, they aren't built for, convenience or a nice view. They're built because there's literally no other way. Absolute necessity.
We're moving way beyond just a simple gondola ride.
Oh, absolutely. We're looking at how these industrial-scale aerial systems become the only way economically, physically to get things done for development, for security in the toughest spots on Earth.
Yeah, and our focus today is on a specific company, M&M Ropeways. They're an Indian engineering firm, and they specialize entirely in cracking these, well, seemingly impossible transport problems.
That's their niche. And their mission, they say, is creating flawless, sustainable, and effective mobility systems.
That word flawless,
Yeah.
it really tells you something about the stakes, doesn't it?
It really does. No room for error. They deliver the whole package, end-to-end solutions. They're not just selling machines. They're infrastructure partners for some really critical national projects.
And that end-to-end control thing you mentioned, that's key.
Oh, absolutely crucial. Yeah, I mean, think about it. They're managing the entire process.
So not just design, but
Everything. From the initial computer designs, the stress analysis, all of that, right through to actually manufacturing their own key components in-house.
really making their own parts.
Key parts, yeah. And then the final installation, the commissioning, even if that site is like 18,000 feet up in the mountains, it's complete ownership.
Wow. Okay, so that vertical integration, that guarantees the kind of flawless performance needed for, say, the Indian Army or these huge hydropower companies.
Exactly. For clients where failure just isn't an option, you can't have a system go down in those situations.
Okay, so based on the detailed profiles we've looked at, our goal today, our deep dive mission, is to sort of pull back the curtain on this pretty specialized world.
Right.
We want to figure out the whole range of stuff they build.
Right.
I mean, it goes from moving people to placing, 50-ton concrete blocks?
Yeah, the range is incredible.
And understand the tech, the engineering mastery needed to build systems that basically shrug off conditions, altitudes, temperatures that would just wreck normal machinery.
And ultimately, why this work, which is often kind of hidden, is actually a really critical piece of the puzzle for national development, for security, that strategic infrastructure link.
Okay, let's unpack this. So let's start with just how diverse these solutions are. M&M Ropeways. When you say ropeway, it's not just one thing. We're looking at, three really distinct categories.
That's right. Three main types. They all use the same basic idea, transport via suspended cable.
Yeah?
But they're engineered for completely different jobs. Moving people, moving vast amounts of material, and then these super precise heavy lifting cranes.
From basic human transport all the way to, heavy construction gear that seems to defy gravity.
And that versatility, that's really key to why they're leaders in this field. They haven't just tweaked one design. They've really mastered the mechanics, the materials, the control systems needed for all three.
Passenger transit, bulk material flow, and this ultra-precise heavy lifting.
Each one needs totally different specs, right?
Yeah.
Speed, safety factors, how you balance the load, how durable it needs to be. It's all different.
Okay, let's start with moving people. M&M definitely builds the kind of systems we might recognize. Cable cars for tourists.
Scenic routes, yeah. Urban transit solutions, maybe, to get over traffic jams.
Yeah.
And amusement parks, that sort of thing.
Standard applications.
Yeah.
Focused on getting lots of people moved efficiently, maybe with a nice view. High throughput, public mobility. That's the commercial side.
Right. But then you look at who their clients are, and the picture changes a lot.
It shifts dramatically, yes.
Yeah.
The big one that stands out is the Indian Army. Having them as a key client, that tells you everything.
How so?
It tells you their baseline for quality, for reliability, has to be way above what even the most demanding tourist operation would need.
Okay, that is interesting. So when you're building for the military, it's not about convenience anymore. It's about strategic readiness.
Exactly. The source material uses the phrase serious reliability.
Serious reliability. What does that actually mean in engineering terms? When you're designing a ropeway for, like, military deployment?
It means you engineer out every conceivable point of failure. Every single one. Think about it. A normal ski lift, power goes out.
Okay.
You fire up the backup diesel, get everyone off safely,
Yeah.
evacuation.
For a strategic military system, maybe operating at 16,000 feet, you need continuous, sustained operation. It has to work. Maybe even under really bad weather or potentially even, contested conditions.
Wow. Okay, so that needs layers of backup.
Several critical layers. First, redundancy. Power, control systems, multiple independent power sources, maybe even its own micro hydropower nearby, or advanced battery backups, so it works even if the main grid is down.
Right. Power independence.
Second, hardening, making the actual mechanical systems tougher, higher tolerances for vibration, for sudden temperature swings, maybe even resistance to things like electromagnetic pulses.
So it's not just a beefed up cable car, it's basically a hardened supply line that happens to be in the air.
That's a good way to put it, yeah.
Does that military requirement change how they test these systems
Mm.
compared to the standard commercial tests?
Oh, absolutely. Commercial ropeways, strict inspections, regular checks, of course. But military systems, they often need non-destructive testing, NDT that's probably unique to M&M, plus they almost certainly use digital twins.
Digital twins, like computer models.
Exactly. Sophisticated computer models of the entire system. They can simulate decades of wear and tear in days. Component fatigue under heavy loads, those extreme cold cycles we talked about, maximum stress over and over.
So they're testing it virtually, constantly, to find problems before they happen in the real world.
Predicting and preventing catastrophic failure before it occurs. That's the goal. They can't afford for it to fail in the field.
And that super rigorous standard, which comes from this military need,
Yeah.
that then becomes the standard for everything else they build.
That's the implication. That baseline of toughness, of resilience, it filters down.
So their regular clients, say a tea estate, they're getting something built with a level of engineering that was originally demanded by the military.
Precisely. If a component is engineered to work flawlessly at minus 35 Celsius for the Army, then that same type of component used somewhere less extreme, like a tea plantation. It's going to last a very, very long time with minimal issues. It vastly exceeds the basic requirements.
Okay, let's pivot now. From people to the really heavy stuff, these material handling ropeways, the source calls them the industrial workhorses.
And they really are. These systems tackle a basic logistics problem that trucks often just can't, especially in mountainous places like India.
Why not trucks?
Well, look at the terrain they're often dealing with. Deep ravines, maybe ecologically sensitive areas you can't build roads through, slopes that are just too steep or too unstable for road construction.
Right.
In those situations, moving material continuously by cable is often the only practical choice. Think about building and maintaining a temporary road for heavy trucks in those conditions. It's incredibly expensive, it's dangerous, and the environmental damage can be huge.
And the capacity figures they mentioned. This is what blew me away.
Yeah.
These industrial ropeways can move loads equivalent to hundreds of dump trucks every single hour.
Hundreds. Let's put that into perspective because it's kind of the aha moment for understanding the scale here.
Yeah.
A big dump truck might carry, 20, maybe 30 metric tons? If a ropeway moves the equivalent of hundreds of those every hour,
Yeah.
you're talking thousands, maybe tens of thousands of tons a day, just flowing constantly.
Wow. And imagine that on the ground. That's a massive convoy of trucks, right?
Yeah.
Stretching for miles.
Constant road wear, fuel consumption, noise, dust, dozens of drivers. It's logistical chaos.
The ropeway swaps that batch process for this continuous automated flow, like a conveyor belt in the sky.
Exactly. A perpetual motion machine for materials. And the efficiency gains. They can drastically shorten construction timelines.
And the savings must be huge.
Oh, multifaceted. You avoid the huge cost of building that road in the first place. You cut the operating costs, no massive truck fleet to maintain and fuel. Fewer drivers, less labor needed for ground logistics. The efficiency is often so overwhelming, the ropeway isn't just an option, it becomes the financially necessary choice for these big operations.
And who's using these? The sources list a few key industries. Mining, obviously.
Heavy mining, yeah. Moving bulk or out.
But also tea estates. That surprised me a bit.
Makes sense if you think about it. High-altitude plantations, maybe delicate handling, needed to get the leaves down to the processing centers quickly without bruising. A ropeway offers smooth, rapid transport.
Okay. And then the really big ones, massive infrastructure projects.
Yes. This is where the national impact really shows. They're vital for rural development, just getting basic materials to isolated communities. But they are foundational for huge capital projects. Tunnel building.
Right. Get the excavated rock out.
The spoil, yeah. It has to move out as fast as the tunnel boring machine moves in. The ropeway becomes the circulatory system for the site. And maybe most critical, hydropower projects.
Building dams and powerhouses in these remote, steep locations.
Absolutely essential for those.
That image, the construction site's main artery, just hanging in the air, really drives home that these aren't just helpful extras. They're fundamental to even being able to do the project.
Couldn't do it without them in many cases.
Okay, that takes us to the third category. These specialized cable cranes. This is where it shifts again, right? Not just moving stuff, but precision placement, heavy-duty installation.
Exactly. This is arguably M&M's most bespoke, most technically demanding product.
And here's where it gets really interesting. How on earth do you guarantee reliability when you're basically building giant structures in places nothing else can even get to?
Well, the cable crane's job isn't bulk transport. It's about lifting, suspending, and then positioning extremely heavy, specific components with incredible accuracy. Think of it like performing surgery, but with 50-ton steel sections in the middle of a canyon.
And these for the really big national projects, dams, hydropower. The sources specifically mentioned pump storage power projects, PSP.
Right, let's focus on PSP for a second because it really highlights the challenge. Pump storage power, you basically have two reservoirs, one high, one low. When electricity is cheap, you pump water uphill, store the energy. When demand is high, you let the water run back down through turbines, generating power.
Okay. Standard hydro concept, but reversible.
Sort of, yeah. But the infrastructure needed these huge pipes called penstocks, the turbine parts. The powerhouse itself often has to be built deep inside a really steep gorge or canyon.
Okay, so why a cable crane for that? Why not just bring in a massive conventional crane like you see on city construction sites?
Good question. Because those conventional tower cranes have limits. They're anchored at the base, they have a limited reach, a limited radius.
Yeah.
If you're building a dam across a gorge that's, say, 800 meters wide and 300 meters deep, no tower crane on Earth can reach the middle of that site from the edge, let alone lift a 50-ton turbine casing down there and hold it perfectly steady, especially if there's wind.
Okay, so the cable crane,
Yeah.
it spans the entire gap.
Exactly. It's like a gantry crane, but instead of running on rails on the ground, it runs on massive cables stretched across the whole valley or gorge. Huge towers, head masts, and tail masts anchored deep into the rock on either side.
And the crane carriage moves along those main cables.
Right. The carriage traverses the span, carrying the heavy load. It can lift, lower, and move side to side across the entire construction area below. It picks up a massive prefabricated piece, maybe a section of the dam wall, maybe a turbine generator, carries it out over the void, lowers it hundreds of feet, and holds it rock steady, millimeter precision, while crews bolt it into place.
That sounds incredibly complex. The control systems must be totally different from a simple material ropeway.
Oh, night and day. You need absolute precision, minimal sway, even in wind. Constant feedback to the operators about load, position, wind speed.
What kind of tech makes that possible?
You're talking advanced dynamic braking systems, sophisticated anti-sway technology, maybe using secondary guide ropes or active damping, real-time load cells on everything. When you're positioning a critical piece of a dam, the tolerance might be just millimeters.
Millimeters, with tons hanging in the air.
The success of some of India's biggest, most strategic energy projects literally hangs on the flawless, precise operation of these aerial cranes.
This ability to build where building seems impossible, that's got to be their core strength. But yeah, back to the main question. How do they do it? How do they maintain that precision, that heavy-duty performance, when they're operating right on the edge of the inhabitable world?
And that really is the core technical challenge, isn't it? It's what sets M&M apart. Designing for huge capacity is one thing. Guaranteeing that capacity when it's minus 35 degrees Celsius outside and the air pressure is half what it is at sea level, that's another lead entirely.
Yeah, we need to look at the specific numbers here, the figures that really define them as extreme environment specialists. These are the limits that make them different. Hashtag tag 2.1, defining extreme performance capabilities.
Okay, let's break down the environmental extremes they handle. First up, altitude. They have installations operating as high as 18,000 feet.
18,000 feet. Just to give people context, that's What, higher than Everest Base Camp?
It is significantly higher than South Base Camp. We're talking serious altitude.
Okay, obviously that's tough for the work crews, the thin air.
Mhm.
But what does that altitude do to the machinery itself? It must be more than just people getting tired.
Oh, much more. You've got, I'd say, three major engineering headaches at that height.
Okay.
Structural integrity and wind. At 18,000 feet, you're often above the main weather patterns, which means you can get hit by incredibly strong, sustained wind shear and rapid pressure changes. The towers themselves need superior design, stronger materials, deeper foundations just to stay standing and resist those forces.
Makes sense, too.
Power systems. If you can't connect to the main grid, you rely on backup generators, usually diesel. But at high altitude, the air is thin. Less oxygen means internal combustion engines lose power. It's called deaerating. They just don't burn fuel efficiently.
So you need special engines.
Specialized engines, often turbocharged to force more air and maybe proprietary fuel systems. Or you just have to use much bigger, oversized engines than you'd need at sea level to get the same horsepower. It's a major challenge.
Okay. And number 3.
Ice and material stress. You get complex ice formation at that altitude. Rime ice, glaze ice. Plus, the constant freeze-thaw cycles put immense stress on cables, on the sheaves, the wheels the cable runs on the towers. Materials need superior corrosion resistance, and they have to be designed to handle fatigue from those cycles.
Right. And then you layer on top of that altitude the temperature requirement. You said systems designed to work flawlessly down to minus 35 degrees Celsius.
Minus 35°C. Yes.
Now you're adding the risk of things just becoming brittle.
Right.
That extreme cold brings a whole different set of potentially catastrophic risks.
Absolutely. The biggest danger is called cold-induced embrittlement. Normal steel, standard grades, they lose their toughness, their ductility. Below certain temperatures, they become brittle like glass.
So sudden impact or just the stress of normal operation?
And a critical part, like a sheave or a joint in the tower, could just fracture instantly, catastrophically. No warning.
So how do they prevent that? Special materials?
They have to use specialized materials. Proprietary low-temperature alloy steels for anything critical. These maintain their toughness, their impact resistance, way down below freezing. It's advanced material science. And think about lubricants. Standard grease, hydraulic fluid, at minus 35, it turns into solid wax. Useless.
Why? The system wouldn't even start.
Exactly. So they need specialized synthetic lubricants that stay fluid. And often sophisticated heating elements built right into the drive units, the gearboxes, just to keep things viscous enough to operate, especially on startup.
So it's not just about building strong towers. It's metallurgy, it's thermal management.
Right.
The whole system has to fight the physics of extreme cold and extreme UV radiation at altitude too, right? That degrades plastics and seals.
It's a completely holistic approach. You need top-tier structural engineering, yes, but also advanced material science and, as the source highlights, incredibly meticulous logistical planning just to get the parts there and assembled. It's about ensuring not just that it works on day one, but that it keeps working reliably for decades in these incredibly hostile places. Hashtag 2.2, adherence to global safety benchmarks.
Okay, given all the extreme conditions, the military clients moving these enormous loads, quality control, safety, it can't just be good. It has to be absolute, world-class, non-negotiable.
That commitment to global safety standards is the bedrock. It's the guarantee that mitigates the inherent risks of operating in these environments. It assures the client, whether it's the government or a private company, that the system isn't just tough. It's also designed and built according to the strictest international benchmarks.
And the sources list their credentials. They're ISO certified.
Standard for quality management, yes.
And crucially, all systems designed according to BIS and OITAF guidelines. Now, BIS, that's the Bureau of Indian Standards, the national benchmark. But OITAF, you call that the International Gold Standard. What is that?
OITAF. It stands for the International Organization for Transportation by Rope. In French, Organisation Internationale de Transport à Câble. It's basically the global authority, mostly driven by European engineering expertise, historically from places like Switzerland, Austria, France, Italy, the Alpine countries where ropeways were pioneered.
Oh, okay. The experts.
They set the definitive technical specifications, the safety factors, the operational rules for all kinds of aerial cableways worldwide.
So following OITAF isn't just like a nice badge to have. It actually dictates specific engineering choices.
Oh, highly specific. It mandates things like minimum safety factors for the main cable, how much stronger the cable has to be than the maximum calculated load. It sets limits on how far apart towers can be. It demands really stringent schedules for non-destructive testing of critical parts, detailed requirements for emergency brakes, evacuation systems.
So if a company says they build to OITAP standards, they're signaling a very high level of technical rigor, probably above just the basic national standard like BIS.
Generally, yes. It means they're meeting the highest international benchmark. It tells clients, especially international ones or those involved in critical projects, that the system incorporates decades of global experience and safety knowledge.
Mhm.
If you're building a system to carry hundreds of people or build a strategic dam, you want that level of assurance baked into the design.
Right. You want the global best practices, not just local ones.
And that ties into their staffing strategy, too. The source mentions they blend their own in-house Indian experts with professional European design engineers.
Okay, why do that? Just for the OITAF compliance.
Partly, yes. It's a functional necessity to ensure those OITAF standards are truly embedded in their design process. The European engineers bring that deep, specialized knowledge of the latest global standards and techniques, but it's a two-way street.
How so?
The in-house Indian experts bring absolutely invaluable knowledge about the local conditions, the specific geology of the Himalayas, the unique wind patterns in certain valleys, the particular types of ice formation they encounter, things a purely European team might not fully appreciate.
Ah, so it's a synergy. Global standards meet local expertise. International rigor combined with hard-won, on-the-ground experience in those specific challenging environments.
Exactly. That combination allows them to maintain that world-class technical performance while actually delivering these incredibly complex projects successfully in very specific, very demanding local contexts.
Okay, so the technical skill, the mastery of extreme conditions, that's clearly essential. But just being good engineers isn't always enough to succeed in these huge, multi-year, often multi-billion-dollar infrastructure deals, right?
No, you need a solid business strategy too. And looking at the sources, we can see what looks like a clear blueprint for M&M's success. Beyond just the engineering, there seem to be about 4 key pillars giving them a strategic advantage.
Right. These pillars explain how they actually win and then deliver on these massive contracts. It shows they're pretty savvy in their business model, their project management, even how they help clients finance these things.
As sophisticated in business as they are in metallurgy, you could say. Hashtag tag 3.1. Proven track record and decades of experience.
Okay, pillar number 1 seems pretty straightforward. Sheer experience. They've been doing this for over 35 years and delivered more than 120 projects.
That's not trivial. In the world of high-stakes infrastructure, that history, that track record, it's maybe the single most important risk mitigation factor for a potential client.
Why is it so crucial?
Think about it from the client's perspective. Maybe it's a government agency or a big developer planning a 4-year hydropower project costing billions. Their biggest worry: execution risk. Will the contractor deliver on time, on budget, without major problems?
Right.
That 35 years and 120 plus projects, it's hard proof. It quantifies M&M's reliability. It means they have this huge internal database, essentially covering every single part of the project lifecycle.
What kind of data?
They likely know the real-world failure rates of specific components they installed 15 years ago at 15,000 feet. They know how monsoon rains typically impact installation times in a certain region. They have data on soil stability for tower foundations in different geological zones.
So that historical data lets them predict things more accurately, design better, plan better.
Exactly. More accurate forecasts, better risk planning, more realistic schedules that they can actually defend. For a client facing huge financial risks, that proven history is it's like invaluable insurance against delays and cost overruns.
Each of those 120 projects must add to this massive internal library of knowledge. Lessons learned about logistics, about how materials really perform under stress, about the best maintenance routines.
It gives them a huge head start over any newer company trying to break into this very specialized market.
Creates a pretty high barrier to entry, I'd imagine.
Almost insurmountable for smaller players, yeah. Plus, that long history means they've built up really strong, reliable supply chains. They know who to source high-quality steel from, who makes the best electrical components. They have relationships that ensure quality and timely delivery, even for specialized stuff. Hashtag tag 3.2. Complete end-to-end control. The huge edge.
Okay, pillar 2. This is the one that the sources explicitly call a huge edge. Their complete end-to-end control. Managing the whole thing, design, engineering, manufacturing, supply, installation, the full cycle.
Yeah, that vertical integration.
Hmm.
In highly specialized critical machinery like this, it's almost a prerequisite for guaranteeing quality.
Why can't they just outsource parts?
Well, if M&M had to rely on outside companies for, say, the main drive mechanism or the load-bearing sheaves, they'd constantly be fighting potential problems. Quality variations from the supplier, delivery delays, maybe even issues protecting their own design secrets, their intellectual property.
Yeah.
By owning the whole chain, especially the critical manufacturing steps, they ensure what gets built perfectly matches the high-level OITAF design specs. There's no gap between design intent and the final physical part.
And the sources are specific about which parts they make themselves.
Huh.
The drive units and the sheaves.
Mm.
Let's dig into that. Why are those two components so critical to make in-house?
Okay, the sheaves. Those are the grooved wheels the main cable runs over on the towers and in the stations. They are under immense, constant dynamic load and friction.
Right, they take a beating.
If a sheave fails, cracks, bearing sees the whole system could potentially come crashing down. It's a critical failure point. So making them in-house lets M&M control the metallurgy exactly. They can use that specialized high-quality steel alloy we talked about, ensuring it has precisely the right fatigue resistance, the right toughness for the specific temperature and load conditions. They're not relying on an external foundry's quality control.
Okay, that makes sense for the sheaves. What about the drive units?
The drive units are the heart of the system, the powerhouse. They contain the main electric motors, the powerful gearboxes, the braking systems, everything that makes the ropeway move and stop safely.
The brains and the brawn combined.
Exactly. Manufacturing these in-house means they control the precision of things like the gearbox assembly. When you're moving tons of material or positioning a heavy crane load, that gearbox has to handle huge fluctuating loads and speed changes with absolute precision and zero slippage.
Demands high precision manufacturing.
Very high. Specialized machine tools, incredibly rigorous testing protocols during assembly, maybe proprietary quality checks like magnetic particle inspection or ultrasonic testing on welds and gears. Things that are really hard or impossible to guarantee if you just buy a standard industrial gearbox off the shelf and try to adapt it.
So they control the parts most likely to fail under stress or wear out. That makes sense.
Yeah.
But let me push back a bit here. Isn't full vertical integration kind of risky too?
Of course.
Well, if you make everything super specialized and proprietary in-house,
Right.
doesn't that make you less flexible? Maybe limit your ability to scale up quickly? What if there's a bottleneck in your own factory? Or what if one of your unique parts fails in the field and getting a replacement takes ages because only you make it? Supply chain fragility.
That's a really good point, and it's a classic challenge with vertical integration. But it looks like M&M's approach is smarter than just make everything. It seems to be strategic integration.
Meaning?
They're very selective about what they manufacture internally. They focus their own resources, their internal expertise on the absolutely critical, high-stress, proprietary mechanical components, the sheaves, the drives, the parts where their specific know-how adds the most value and ensures the most safety.
Okay. So what about other parts? Electronics, control panels.
Right. For more standardized components, things like the electrical control systems, the PLCs, programmable logic controllers, sensors, maybe even the cabins themselves, the source suggests they strategically source these from other top Indian companies.
Ah, so they leverage the expertise and scale of other domestic suppliers for the less unique parts.
Exactly. It's about optimizing the supply chain. Get the best quality and cost efficiency on the more commodity high-tech parts from specialized suppliers while keeping the absolute core mechanical integrity and proprietary designs tightly under their own control. It's a balance. It gives them quality control where it matters most, but also resilience and scale by using external partners strategically.
Okay, so that technical excellence and strategic manufacturing, that translates into real benefits for the client. That's the third pillar, right? Operational efficiency and, interestingly, financial flexibility.
Right. The operational efficiency parts is pretty clear from what we've discussed. These ropeways mean streamlined logistics, faster material movement compared to trucks on bad roads, less downtime waiting for transport, reduced handling time.
Which all adds up to lower costs for the client.
Directly measurable savings, lower labor costs, lower fuel costs, potentially shorter project timelines, which saves money overall. The operational savings across a 20 or 30-year project lifespan can be absolutely huge.
But the financial flexibility part,
Yeah.
that seems like a really clever strategic move. They don't just sell you this massive, expensive machine. They offer leasing and investment options.
This is huge, especially for the kind of clients they often work with. Big infrastructure developers, maybe government entities working on these massive national projects like hydropower dams.
Yeah.
For them, managing cash flow and capital expenditure capex is absolutely critical. Buying a multi-million-dollar ropeway system outright is a massive upfront capex hit. It ties up a huge chunk of capital right at the start of the project.
Capital that they might need for other things, like, actually building the dam.
Exactly. Money they could use for pouring concrete, buying turbines, meeting payroll, hitting contractual milestones.
So by offering leasing or some kind of structured investment deal, M&M is basically turning that huge one-time purchase
Into a more manageable operational expense, an OpEx, spread out over the duration of the project, maybe paid monthly or quarterly.
like renting the system instead of buying it.
Essentially, yes. And this financial structuring is incredibly helpful for the client. It frees up their precious capital reserves for other immediate needs. Plus, depending on the specific tax laws and contract structure in India, leasing might offer the client significant tax advantages or different depreciation benefits compared to buying.
So it makes it much easier for a client to say yes to getting the state-of-the-art system. They don't have to face that paralyzing upfront cost.
Precisely. It lowers the financial barrier to entry. M&M isn't just selling an engineering solution, they're selling a financial solution too. It shows they really understand the client's whole business context, not just their technical need for a ropeway. It reduces the overall risk profile for the client adopting this specialized tech. Okay, so we've covered the tech, the business strategy. Now let's shift focus a bit to the bigger picture, the wider impact. Because this infrastructure, it's not just a tool for building things. It's actually a vital piece in solving some really fundamental national challenges, things like safety, environmental impact, and maybe most importantly, national security.
Right? This section really positions M&M Ropeways as operating at a level that influences policy. They're providing solutions where the old ways roads, trucks are just too dangerous, too polluting, or maybe literally impossible to use reliably. Hashtag tag 4.1, enhance safety in dangerous terrain. Let's start with safety. The sources draw a direct line between these custom-built automated ropeway systems and the very real dangers of using trucks in hazardous terrain. Steep mountain roads, landslide-prone areas, road accidents are a grim fact of life there.
The safety comparison is incredibly stark. Think about building a huge dam or tunnel way up in the mountains. You need a constant flow of heavy materials, rock, cement, steel. Doing that with trucks means hundreds of trips a day, often on temporary, winding, unstable roads.
Yeah, sounds risky.
The risk to drivers, to other workers on site, from rock falls, from vehicles losing control on sharp bends, from bad weather making roads impassable, it's significant. Sadly, the fatality and injury rates associated with heavy logistics in those high-altitude construction zones can be quite high.
So the ropeway takes people out of harm's way.
Dramatically reduces the human exposure to risk. You're replacing hundreds of individual truck journeys, each with its own potential for accident, with one continuous, automated, centrally controlled system. A system built to those stringent OITAF safety standards we talked about, with multiple built-in fail-safes, remote monitoring.
So fewer people are directly involved in the transport process itself.
Exactly. You essentially automate the most dangerous part of the logistics chain. That inherent safety benefit is a really powerful reason why clients, both government and private, choose ropeways for these high-risk projects. They want to minimize workplace accidents and avoid the project delays that accidents cause.
And it's not just the construction workers, right? Taking hundreds of heavy trucks off those often narrow, fragile mountain roads must make things safer for local villagers, for other traffic too, and less wear and tear on the local roads.
That's a great point. It's a systemic safety improvement for the whole region, not just the project site. #tab 4.2, environmental sustainability. And that connects nicely to the next point, which is often overlooked, the environmental side. What's fascinating here is how this specialized infrastructure kind of manages to tick both boxes. It's economically efficient and it offers real environmental benefits.
The most obvious one is emissions, I guess. Fewer diesel trucks means less pollution.
That's the big one, yeah. The reduction in carbon footprint can be massive. Over the life of a multi-year construction project or a long-term mining operation, the electricity needed to run the ropeways motors is generally far, far less polluting than burning diesel in hundreds of heavy trucks day in, day out.
Especially if the electricity comes from a clean source.
Right. And the source material mentions M&M's commitment to sustainable mobility. That suggests it's probably about more than just cutting emissions.
Like what else?
Think about the physical footprint. Building a road through mountains means bulldozing, cutting into slopes, grading huge areas. It causes soil erosion, it fragments animal habitats, it leaves long-term scars on the landscape.
Okay. And ropeways.
Ropeways have a much lighter touch. You need foundations for the towers, yes, but the towers are widely spaced. The system transports materials over the sensitive terrain, not through it. You avoid cutting massive roads through forests or across fragile alpine meadows.
So less disruption during construction and less long-term damage to the ecosystem, especially important in high-altitude areas or protected zones.
Exactly. It minimizes the long-term impact. And often, especially with hydropower projects, the ropeway can be powered directly by the clean energy being generated locally, maybe even by the very project it helped build.
Closing the loop.
It creates this virtuous cycle. The energy-efficient ropeway helps build the clean energy source. It's a genuinely greener logistics solution compared to the alternative of constant heavy truck traffic, which can be environmentally quite destructive. And that aligns really well with national goals around sustainability. Hashtag 4.3, a vital link for national security and development.
Okay, this brings us to what feels like the ultimate strategic point.
Yeah.
Moving beyond just commerce and the environment into national policy, national defense. The idea that while we might associate ropeways with tourism, their real deep significance is their ability to operate where literally nothing else can,
Yeah.
making them essential strategic assets.
This is where the company, M&M, becomes more than just an engineering firm. They become arguably a critical national asset themselves. Their work is a vital link for two key things. Broad national development, opening up previously inaccessible areas for economic growth, connecting remote communities and specific national security needs.
The most direct security link is that partnership with the Indian Army we discussed earlier, ensuring year-round supply lines, year-round access to remote border regions. These aren't just supply routes, they're strategic arteries.
You have to consider the geography, especially along India's high-altitude borders. Roads in many of these areas are completely seasonal. They get shut down for months, sometimes half the year, by heavy snow, by landslides, by ice.
So ground supply just stops.
Completely cut off. During those critical months, the only way to resupply border outposts might be by airdrops, helicopters, or planes, which are expensive, very weather-dependent, and can only deliver limited amounts intermittently.
Okay. And the ropeway changes that how?
The ropeway, because it suspends the transport line hundreds of feet above the ground, it bypasses all that chaos. The snow, the landslides, the ice on the ground, they don't stop the cable car. It provides a permanent, reliable, year-round connection.
Wow. All weather, all seasons.
It becomes a fundamental piece of India's strategic infrastructure in those regions. It transforms the strategic situation. Outposts or bases that were once effectively isolated for half the year become reliably connected 365 days a year.
Oh.
That drastically enhances national security readiness, force posture, the ability to sustain presence in those critical border zones.
That continuous connection is a massive military advantage. But does it also create a new vulnerability? If this single ropeway becomes the only supply line, isn't it a really tempting target? Maybe more vulnerable than a whole network of roads.
That's a very sophisticated crot, and it's something the engineers absolutely have to consider in the design, especially for military systems. You weigh the vulnerabilities. A road network might seem resilient because it's spread out, but it's also vulnerable at many, many points bridges, narrow passes, culverts, easy to block or sabotage. Landslides can cut roads easily.
Okay. And the ropeway?
An aerial ropeway is a single line, yes, but it's engineered for resilience. The key towers can be placed in deliberately inaccessible locations, maybe on cliffs or within heavily guarded areas. The control systems themselves would need robust cybersecurity to prevent hacking or remote interference. But perhaps the biggest resilience factor is the redundancy and repair capability built in. We talk about backup power. If a section of cable gets damaged, or even if a tower is compromised, the system is likely designed for rapid, modular repair. And often, they have ways to maintain at least partial operation, maybe at reduced capacity, while repairs happen.
So designed to be fixed quickly, designed to withstand damage.
That focus on operational resilience is key to its strategic value. It's not just about providing access, it's about providing reliable, sustained access. It fundamentally changes the equation for defense, for economic development, even for things like delivering healthcare or disaster relief. In these incredibly remote, seasonally cut-off regions, they become reliably connected zones.
So what does this all mean? Hashtag tag outro. Well, this deep dive into M&M Ropeways, It's really opened up a window into this incredible world of extreme engineering, hasn't it? We've gone way beyond just thinking about transport. We've seen the sheer versatility moving people, shifting mountains of material, precisely placing huge dam components.
All using that core cable technology, but engineered to incredibly high global standards like OITF.
Yeah, and we got into the technical weeds a bit. That mastery needed to make things work reliably at 18,000 feet or in minus 35-degree cold. The specialized material science for parts like sheaves and drive units, it's really impressive stuff.
And we also saw the smart business strategy behind it, that end-to-end control, giving them a quality edge, and the financial savvy of offering things like leasing options to make these huge projects feasible for clients.
Right. And maybe most importantly, we understood that these systems, these suspended lifelines, they're not just convenient. They're driving safety improvements, they offer environmental benefits, and crucially, they're essential pieces of national infrastructure, providing that vital year-round access to some of the most strategically important and difficult parts of the country.
Absolutely. Which leaves us with a final thought, something for you, our listeners, to maybe chew on.
Okay.
When we think about critical modern infrastructure, our minds usually go to things firmly planted on the ground, right? Roads, bridges, rail lines, pipelines.
Odd stuff.
But what M&M Ropeway shows us is that sometimes the most vital, the most reliable, the most technologically advanced logistical links are the ones literally hanging hundreds of feet in the air, defying gravity, defying extreme weather. So if these absolutely essential supply lines for industry, for defense, for communities depend entirely on things like specialized low-temperature steel and hyper-reliable gearboxes to survive conditions that would destroy anything else, what does that reliance tell us about the true complexity and maybe the hidden fragility or perhaps the necessary engineered resilience of the modern strategic infrastructure that now depends fundamentally on these extreme specialized aerial links just to function?
Wow. That's a powerful thought. The invisible threads holding things together, quite literally a fantastic place to leave it. Thank you for joining us on this deep dive.